In this lesson, we're going to go over complex numbers. You'll be able to combine like terms, multiply, divide, and simplify in the case where we have I squared. And you'll be able to explain how to reduce large powers of I. So let's start off by defining what a real number is. A real number is a number that's irrational or rational. So, for example, the number 5 is a rational number. We could write it as a fraction, 5 over 1. We could say the number negative 3.2 is another example. We could also say the square root of 2, because this is a decimal that never ends. These are all examples of real numbers. The next definition is imaginary number. So an imaginary number is the square root of a negative number. So for example, the square root of negative 3 is an imaginary number. And we'll see in just a minute how to simplify that. A complex number is a number that's part real and part imaginary. So it's combining our first two types of numbers. And it has the form a plus or minus bi. So in this form, here is your real part, the a. And this is the imaginary part because it has an I with it. So this is the imaginary part. The last thing we need to define is we have this letter I in the form of a complex number. So what is I? So the imaginary unit I is defined to be the square root of negative 1. So you want to make sure you write that down. I is the square root of negative 1. If we were to take this I is square root of negative 1 and square both sides, and my square root and my square would cancel out, and I would get I squared equals negative 1. So this is how I get this second result here. I squared is negative 1. We're going to be using both of these to help us work out some problems. So section 1, rewrite in terms of I. So remember, we know I is the square root of negative 1. So if I look at number 1, I have square root of negative 3. We could break that up as negative 1 times 3, because I want to use this fact that I squared is the square root of negative 1. And then we could apply our product property of square roots, where square root of negative 1 times 3 can be broken up as square root of negative 1 times the square root of 3. Well, we know the square root of negative 1. It's I. So I'm going to just put I square root of 3. And you're going to typically see this written as square root of 3 with the letter I after it. But either one of these is fine. So this is how you rewrite in terms of I. Example 2, adding and subtracting complex numbers. You know how to do this already. Basically, you're just going to treat I as if it's a regular variable. So as if it was like an X or Y. You're going to treat it the same way. The only difference here is that your answer needs to be in this form A plus or minus BI. So the term that has the letter I with it just has to come second. So here in example 2, I have negative 2 plus 7i plus 8 minus 3i. So these parentheses are being added. So I can just remove them. So this would be negative 2 minus 7i plus 8 minus 3i. And now I'm going to combine like terms. So negative 2 plus 8 is 6. And negative 7i minus 3i is negative 10i. And this is in the correct form because the term with my I comes second. So example 3, I have 3 plus 6i minus 2 minus 8i. So there's subtraction going on in between the two terms. So I like to think of it as saying negative 1 in front of that parentheses because you have to distribute that first. So when I distribute negative 1 times 2, I get negative 2. And negative 1 times negative 8i is positive 8i. And then I'm just going to copy down what was in the first set. So I'm going to copy down 3 plus 6i. So then combine like terms. So 3 minus 2 is 1. Then 6i plus 8i is 14i. So there's my answer for that one. Multiplying complex numbers, it's the same as multiplying if you were using x's, but there's one difference is that anytime you see an I squared, you replace it with -1, because remember, we defined I squared to be -1. So let's look at some of these examples. So in number 4, I have 3i times -8. So I'm going to multiply the numbers together. 3 times -8 is -24. And I times I is I squared. But remember, anytime you see an I squared, you replace it with -1. So this would say -24 times -1, which is +24. So that's the only difference when you're multiplying, is whenever you see an I squared, just replace it with -1. Other than that, it's just like multiplying as if we had some other variables there that weren't I. Number 5, I times 4 plus 6i. So I times 4 is 4i. And I times 6i is 6i squared. But wait, there's an I squared, so replace it with -1. So what this would say is 4i, and then I'll do 6 times -1, which is -6. Reorder this so that the I comes second. So I would put -6, and then this 4i is really positive because there's no negative in front. So this would say -6 plus 4i. In number 6, we'll do 7 plus 9i times 2 plus I. So we'll basically just FOIL this out. So we'll do 7 times 2, which is 14. 7 times I, which is 7i. 9i times 2, which is 18i. And 9i times I, which is 9i squared. So 9i squared. So what we'll do is right away when we see that I squared, we can cross it off and put -1 there, because we got to replace I squared with -1. And now we can combine our like terms. So we'll have 14. 7i plus 18i is 25i. And 9 times -1 is -9. So now combine like terms one more time. 14 minus 9 is 5. So this is 5 plus 25i. So that's your answer for that one. Section 4, dividing complex numbers. So remember when we worked with square roots, and when we wanted to rationalize the denominator, we multiplied by the conjugate of the denominator. Same thing is going to happen with complex numbers. And the reason why is because when we have I in the denominator, it's really, remember, I is really saying we have the square root of -1. So we're going to basically rationalize the denominator. We're going to get rid of the I down there because I represents a square root. So we're going to use this fact, and we'll also use the fact that I squared is -1. So in example 7, I have -5 divided by -3 minus 4i. So I'm just going to multiply by the conjugate of the denominator divided by itself, just like we did when we worked with square roots. So this would be, the conjugate of the denominator would be -3 plus 4i divided by -3 plus 4i. Then I'm just going to multiply this out. So I'll do -5 times -3 is +15. -5 times 4i is -20i. Divided by, and then in the bottom, I'm going to basically FOIL. So -3 times -3 is 9. And then -3 times 4i is -12i. -4i times -3 is +12i. So then I'll do -4i times +4i, which is -16i squared. Notice I have an I squared, so I'm going to replace that right away with -1. And then simplify this. So this will be 15 minus 20i divided by 9. And then the -12i and the +12i cancel out. Those add up to 0. And then I'll do -16 times -1 is +16. So this would be the same thing, just simplifying would be 15 minus 20i over 25. And you could leave your answer like that, but it would be nice if you'd simplify, because 15, 20, and 25 are all divisible by 5. So this would be 3 minus 4i divided by 5. But either answer would be acceptable. Example 8. So I have 4i divided by 1 plus 2i. So you're going to multiply by the conjugate divided by itself. So 1 minus 2i divided by 1 minus 2i. And then you're going to distribute. So you'll do 4i times 1, which is 4i. And 4i times negative 2i, which is negative 8i squared. Notice I have an I squared, so right away I'm just going to replace that with negative 1. In the bottom, I'm going to FOIL this. So I'm going to do 1 times 1, which is 1. 1 times negative 2i, which is negative 2i. 2i times 1, which is 2i. And then 2i times negative 2i, which is negative 4i squared. Notice again I have I squared, so I'm just replacing it with negative 1. Now simplify. So this, on the top, it's going to be 4i. Negative 8 times negative 1 is positive 8. And then in the bottom, 1, negative 2i plus 2i, those cancel out because those make 0. And then negative 4 times negative 1 is positive 4. And then just simplify. So remember, when we write complex numbers, we want the I to come second. So I'm going to rewrite this as 8 plus 4i divided by 5. Make sure you rewrite it so that the I comes second. So the last section is simplifying powers of I. So basically what we'll do is we'll look at the first 4 powers of I, and then we'll be able to use those first 4 powers of I to help us answer everything else. So I to the first power, remember anything to the first power is itself. So we would have I to the first is just I. So I squared, remember that was just a definition. We defined that to be negative 1. I cubed, we can split up I cubed to be I squared times I to the first. So if we add the 2 and the 1 together, we get 3. So this is just properties of exponents. So I squared is negative 1, and I to the first is I. So this would be negative I. I to the fourth, we can use I squared to help us figure out what I to the fourth is. I to the fourth would be I squared times I squared. I'm just breaking it up like this because I know I to the power of 2 is negative 1. So if I do negative 1 times negative 1, I get positive 1. So this means I to the fourth is positive 1. So these first 4 powers of I, so I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. These repeat themselves. So if we continue this pattern of splitting up by, like for example, breaking up I to the fifth as I to the fourth times I, this would just be 1 times I, which is I. So we can continue this pattern, and what you're going to notice is that these first 4 powers of I that I highlighted repeat themselves. So what I want you to see is that I to the fifth is the same as I to the first. They're both I. I to the sixth is the same as I squared. They're both negative 1. I to the seventh is the same as I cubed. They're both negative I. I to the eighth is the same as I to the fourth. They would both be 1. So this pattern of I, negative 1, negative I, positive 1, this repeats itself every 4 powers on I. So what we can do is, for larger powers of I, we can use this fact to help us simplify the power on I. So our answer for all the problems is either going to be I, negative 1, negative I, or 1. So at number 9, we have I to the 11th. So I'm going to write I to the 11th. And since the pattern repeats every 4 powers on I, I'm going to subtract 4. So I want to get my power on I to be between 1 and 4. So if I subtract 4 from 11, I'm going to get I to the 7. So these would be equivalent. So I to the 11th would be the same as I to the 7th. If I subtract 4 one more time, because I want my exponent on I to be between 1 and 4, this would get me I cubed. Well, that's between 1 and 4. So this, we know I cubed, if you just look up at that chart, I cubed is negative I. So my answer here is negative I. Example 10, I'm going to do this one a little different than the way I did in number 9. So since these repeat every 4, we could take our exponent and divide it by 4. So I'm dividing 18 by 4. It goes in there 4 times. 4 times 4 is 16. So I'm left with a remainder of 2. So when you're dividing, the only tricky part here is when you're dividing, the remainder becomes your exponent on I. So this would be I squared. So I would do I squared, which is -1. So it's very important when you're doing the division method, you need to, your remainder is your power on I. Number 11, I to the -7. So when your exponent's negative, what you're going to do to simplify that power on I is instead of subtracting 4, you're going to add 4 because you want to get your exponent to be between 1 and 4. So you're going to need to add 4 here. So I'll add 4 to that 7. So -7 plus 4 is -3. So this is not in between 1 and 4. So I'm going to do this one more time. So I'm going to add 4. So this is going to be I to the first, which is just I. I want you to try 12 and 13. You can use subtracting by 4 each time, or you can use the division method to help you reduce that power on I. So your answer should be either I, -1, -I, or 1 for these. So try 12 and 13. When you unpause the video, I'll have a solution here for you. So hopefully you gave 12 and 13 a try. In 12, when you do your division, you end up with a remainder of 1. So I to the first is just I. In 13, kind of interesting, what happens when you divide 20 by 4, you get a remainder of 0 because 4 goes into 20 evenly. So your power on I is 0, and remember, anything to the 0 power is 1. So what you're going to notice is that I to the 0 is the same as I to the 4th. Those are both 1. So I to the 0 and I to the 4th have the same value because when you have a remainder of 0, it just means that a number was divisible by 4. Your homework is to complete the MathXL assignment called Complex Numbers.